Good morning, everybody. Hopefully you are all doing well, good in your semester. In the name of Allah, we start the lecture. First, we review the previous content, if you have any questions, any comments, and then we go to the new material. So what did we have? Any questions? Okay.
Will there be like a review kind of midterm or practice?
Sure.
Like a week before?
Sure. So the midterm would be on June 13th in the class. So June 13th is Tuesday. So we will have 11:30 on Tuesday here. We will have our midterm. Yes?
Like when would we get the practice midterm / practice problems to practice before the midterm?
When is good? Next week?
Yeah.
Okay. Okay. And then you work on that, and then we will have a session together to discuss. Okay. The first reflection was grouping ones. We are not many in the class, so I don't go through this list one by one. So, did you have your reflection here? You? Yes. Okay. Which one? Your name? Your name. Ina, okay. Y, then EE. Okay, perfect. Ina. Okay, the question was if we want to group the ones in Carnot map, we could have only limited choice. We cannot use any number of ones. It should be 2, 4, 8, 16, so on. What is the reason? So Ina is saying that the main reason, only groups of 1 in powers of 2 are considered adjacent terms, okay? Adjacent terms share similarities in terms of the variables they have in common. Very good. Because if you put, like, for example, 5 ones, then they don't have common terms, and we cannot make it simpler. But if they are 4, 16 adjacent, then they are good. Even though a row full of 1 is considered Carnot map, a 5-row Carnot map doesn't exist. Therefore, it is impossible. Maybe if we have a bigger Carnot map with 5 rows or 3 rows, even 3 rows, 3 rows of 1, but they don't combine together. They are not good. So we just use 2 rows, and each one, for example, 4 elements, which is 8. Very good, Ina. The next one, torus. Did you put your reflection? Yeah, at the end. What's your name? Let me find it. What? C-A-R-O. Carol. Yeah? Okay, perfect. So the question was about torus. In a 4-variable Carnot map, we have 4 by 4 cells, 16 cells. And then what is the torus? Let's see what Carol wrote. Carol wrote a logic function with 4 variables, has a truth table with 16 rows, which is represented as 16 frames in a Carnot map. A torus, a donut, should be used to draw the Carnot map of 4 variables. And so what does it do if you put it? Example, this. The first solution is this. Okay. Could you explain a little, Carol? I didn't understand your mean. So she said represented a torus should be used to draw or to imagine, because the draw is just a 4 by 4 matrix, 4 by 4 box. Yes, Carol? So Do you know what is Toros? What does it do? You do understand the concept. You don't? Oh, okay. So who else? Maybe you. Yes. Yes.
And it just connects the sides.
Okay.
So if like the furthest right is
So what's your name? So this Jeff. Okay, Jeff. Jeff. Yeah, Geff. Yeah. Okay, Jeff. Very good, Jeff. So this means that you should consider the map be wrapping around around itself like a donut, also known as a torus. This allows cell to be. Okay. Yes. Any questions? Any questions? Perfect, Jeff. So, Carol, we solve another problem today with torus, so please pay attention. And if you had any questions, ask. Okay? Any other questions? Now let's move on. The last examples that we have done is this one. Let me bring it again because you had some questions about it. So this is an example. Okay. How many ones we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9 ones. So we have 9 cells with 1 that we would like them to group them together and then find the implicant and then prime implicant and then essential prime implicant. We had done this last time. So the implicant that we could see here is this one, is let's say this and that. Again here, 4 ones. That's it? Any more? So we had 2 groups of 4 ones, and then we had 3 groups of 2 ones. Any more? Do you find anything more? It doesn't seem so. Then we looked at the essential prime implicants. Which one are essentials? Well, let's mark the cells that indicate essential. For example, in this 4 one, this cell hasn't been covered by anything else other than that implicant. Okay? So it makes this as an essential implicant. For these 4 ones, this cell and this cell, these 2 haven't been covered by anything else. So again, this implicant is essential. So we have now 2 implicants. For this one, the two ones here. So the first one is covered by the other thing, the next one is covered by the down, so it is not essential. For the next one, the first one is covered by this implicant, the other one is first, so it is not essential. For this one, the one that comes from the 2 corners, this cell seems not, oh yeah, there is another one you didn't mention. Yes, please.
Oh yeah, I'm wondering if the top left one there, is it not covered by the
Yes, that's what we are missing because we haven't drawn that. So another implicant is this that we didn't draw. This plus this. Yes? These 2 also are implicant, and so this one is not for essential. But again, here we still have this one. So that one is essential. The first 4, this was essential, and none of them is essential because all of them is covered by something else. So if you look at that, we have these 2 as the essential prime indicating implicant, and the other one as prime implicant, not essential. Now we have to select from those implicants who will cover all of the other ones, all of the ones. and try to make it minimum. So we already had covered 1, 2, 3, 4, 5, 6 ones with these two essential prime implicant. 3 ones are left. So 3 ones. Let me highlight them. 3 ones. Highlight them with green. So this one, and this. These 3 are left after we picked our 2 essential prime implicants. Now we have to select. What do we select? We have 4 implicants. Let me put a number there so you tell me which one I should select. So we have the first one. How do I write it? It's hard. Let me erase everything. Yeah, one of them is the one is red, dark red. This one, this and this. Yani these 2, this and this. Yeah, this is 1. 2 is light red. Yeah, I mean this and this one. 2 is light red. 1 is dark red. 3 is yellow, this yellow, 3 yellow. And 4 is the blue, the dark blue. Okay, you see 4, yeah? So you tell me at the corner. Yeah, raise your hand so we will make sure. Yes, no, yeah, okay, yeah. So what's your name? Mega? Yep. Okay, Mega. We have 3 ones. This one, and this one. Okay. Pardon me? Okay, I put the mark on that. So I will highlight them now. So this one, this, and this. We have 3 ones left because the 6 ones at the top, they have already been covered by our 2 essential prime implicant. Okay? So we have 3. And then we have 4 groups. 1, 2, 3, 4. You know which one are there? 4. The first one is dark red. Is this one? Look at my mouse. This and this. This is the first group. The second one is light red. This one and this one. The third one is the yellow. Yellow is here. And the fourth one is blue. Blue is here. So you have 4 groups. Okay? Could you see the 4 groups? Okay. Now I want you to pick from these 4 groups something that could cover all the 3 ones here which are left. Pick. Tell me the number. 1, 2, 3, 4. Which one do you pick? Pick something. Don't worry. 2. So the 2 is light red. Light red is this and that. So I put this on this. So with your selection, 2 of them are gone. Only 1 left. For this, the one that is left, which one do you pick? I guess it has the blue one and the yellow one. 3 and 4. Which one do you select? 4. Perfect. 4 is blue. So you selected this. Now, with picking 2 groups, you have covered all the 3. Okay? So that's done. So now let's write the expression. Again, I repeat what was your name? Mega. What Mega said? Mega said we pick number 2, number 2, and number 4. He selected these 2 out of these 4 groups. So let's write, and it's full, yeah, it's covered. So all of our ones are covered now. The 6th one with those 2 prime, essential prime, and the 3 ones at the below with these two groups which which have been selected, mega selected. So let's write it down. So the first one, the green one with 4 ones, what is it? Somebody tell me. These four are A naught, C naught. Perfect. So A naught, C naught is the first group. Then we have the blue one with 4, this row. So C naught, C naught and D, C naught D. And then we have 2 groups which Mega selected. So Mega, could you tell me what is the expression for number 2? Number 2 was this and this. What is the expression? We have B naught. You know how to do that? No, you know. Oh, so you have to practice. So these two common B naught and also C D naught. B naught, C D naught. So from the selection of Mega, we reached this. But this is not the only answer that we could find. You could select two other groups other than 2 and 4. For example, we could select one and the yellow one, 1 and 3. Yes. On the lights. Okay. Yeah, there should be some control here. I try and let's see what. Yes. No. That's we should be able to do this. That this light should be turned off. I try. So what happened? No. Okay. No, this is not good. So I put it back. Well, I want to turn off this one. That was good. It's very confusing. I hope that this one better. Let's keep it like that. Yeah. Let me also put this. So it's some kind of presets. Okay, it seems that I have 1, 2, 3, 4, 5, 10 presets. So this is the number 4, remember. Number 5. So then you go to sleep, I guess. It's not good. You go to sleep, and I would just talk for myself. Number 5. No, number 4 was, I guess, is better. It's not perfect. I wish we should have something that turned it off and the rest on. Okay. Hope it's better. Is it better now? Yeah. Okay. I can turn it down, but then then you go to sleep. So this was the first solution. We could have more solutions, and I have put all of the possible solutions, which was 3. Last time I thought it might be more, but it seems that there are 3. So again here you see we have these 2 essentials, and then we selected yellow and the red. So this will come to this. C naught D naught plus A naught, C naught D plus A naught C naught is the essential. So they should be there. But we selected the next 2. This is our selection, the first. You could use another selection. Here we selected this and this. That's okay. In the next one, you selected this and this. So that's another selection, which will come up to this function. So all of these 3 functions, they actually represent our function, represent this Carnot map, but with different choices. So it's possible that you have it. But the thing is that these 2 terms which are essential prime implicant, always there. They are always there. But the rest we could select. Questions? No. Okay. So now go to torus, which I forgot her name, your name. What was your name? Carol, yeah? Carol, okay. So Carol, this is an example for torus and convert and mapping. So let me start finding ones. Oh, the one is, this is easy. This is easy, I guess. No, I don't put that. This is another one. What else do I have? I didn't select these 4 because this is what I want to show you. These 4 together, they make a group. These 4. When you make it, consider it as a torus, so the top row and bottom row and the left and right, they are adjacent. If they are adjacent, it means that these 4 are adjacent together. These 4 are adjacent, and we can select them. So what else? I cannot see. Oh, okay. There is one here. Let me put it with green. There is one here also. This one. So we have 3 groups of 2 ones, 1, 2, 3, and 1 group of 4 ones. Now we have to find the essential ones. So let's see which one makes them essential. I highlight. So the 4, the 4 one group, it's of course it is essential because this one, they are not covered by anything else. So it's essential for sure. Now let's go to the next one. For example, this one, the horizontal green, this is not essential because this and then those of them are covered, so it's not. This one, the first vertical green, this seems essential because this cell isn't covered by anything else, so this is essential. And here, again, this vertical green one, it is not essential because both of the ones are covered by something else, so this is not essential. So it means up to now we have 2 essentials. So let's see what these essentials are covering. So I put blue. So if we select this group and this group, then we have already covered these values, these ones. So what is left? Oh, okay, only one is left. Only this is left. And we have to pick a group which covers that. So only this one is left. We have how many options? 2 options. Either selecting this, the vertical green, the horizontal green, or that. Yes, please. For what?
To cover the last one?
The last one, yes, this one. Yeah. Oh, okay, you mean this. Yes. A, C naught, D. That's right. So this is the one. This is this one. Or you could select this also. This is also acceptable, which is A, B naught, B naught, A, B naught. No. What is that? This is A, B naught, C naught. A, B naught, C naught. That's right. A, B naught. So either we select A, B naught, C naught, or this one which is C naught, D with A. Okay. Do we have it? Oh, okay, yeah. So the first B naught D naught is the 4 group. Oh, we didn't write that. So let me see. So the four ones, which are the 4 coordinates, they are B naught D naught, B naught D naught. So the 4 ones are B naught D naught. The other essential, which is this one, is D A B. The other one is D A B, A B D, A B D. Okay. But the next two, we had the choice, we had option. So these two, B naught D and A, B, D, they are essentials. These two are essentials. The next one would be optional, so you could use either this one or that one. We picked something. Okay? So up to now you got the idea. Start with the Carnot map, group the ones together, find the prime implicants, the implicants that are not fully covered by anything else, find the prime implicants, and then detect the essential prime implicants, then pick those essentials and see what is left, and then select the prime implicants who covers the remaining ones. Yes?
Is there like a rule or a way of looking at it where you know that one is not, like, that there's an implicant left that you can choose between?
Yes. So what is the question?
Like, how do you know?
Just looking at that. For example, here, these two terms, A, B, D, and B naught, D naught was essential. Okay? So let me erase here. So these two terms correspond to B naught, D naught is the 4, this 4, and ABD is these cells. So if I just say that, okay, I have already covered this first and this. Now we look at the map. Which one is left? Which one? Is there any one that we haven't covered it? Yeah, this one. Yeah, this one. Okay? This is not covered. So you should pick a prime implicant which covers that. So either we select this implicant which is here, or you could also select this prime implicant. This is also correct.
So you take all the essential prime implicants, and then you
mark the one that you have already covered.
And then you can see which ones aren't essential prime.
Exactly. Which one isn't covered?
Yeah.
No, the essential means implicant. So you look at the one and then see which ones are not covered. Okay? Yeah? Got it? Okay. Any questions? Okay. Now we have talked about 2 variables, which was a very simple Carnot map, only 4 cells, and then we saw 3 variables, which was 8 cells, 2 rows with 4 columns. Then we saw 4 variables with 4 by 4, and now let's go to 5 variables. When we have 5 variables, it means that we have 32 cells, 5 variables, okay? 32. And usually in a 2D map, we cannot go more than 2 in each row. So what should we do? What we do is using 2 4-variable Carnot map. We use 2 of them together. Each corresponding of these 2 are adjacent. I will show you. For example, here is the one. As you could see here, look at that. We selected 2 Carnot maps. Okay. One of them corresponds to A when A is 0, The other one corresponds to when A is 1. The rest is the same. For example, here you have BC 00011110 and 00011110 for DE. The same thing for both Carnot maps, but the left one is when A is 0, the right one is A1. And here, when you want to consider adjacent terms, all of the things that we have told about the 4 variable is correct here. For example, this one, they are adjacent. Or let's say this is adjacent. They are adjacent. So the things that we have already talked about. But you should also consider the corresponding cells of these to the next map. For example, if we have 1 here, these 4 ones, so we know that they can form a group. But let's say we have also 4 ones here. So if you put them on top of, put this one on top of the other one, you see that they are adjacent. And now we have a group of 8 ones. Or let's say, for example, we have a 1 here, we have a 1 here. So if you put them on top of that, it means that these 2 are grouped together, can be grouped together, this one and this one. So you should consider these 2 on top of that, and each cell, each corresponding cell, they can group together. Each corresponding square of these 2 4 variable are adjacent. So these 2 red one that I put, they are adjacent. And also the 8 ones that we had at the corners, they are all adjacent. Okay. So now let's do some examples. First example. Look at the ones. Let's find the implicants. The first thing that I can see when you put them up to each other, that this one and this one, they are implicants and they are adjacent. So our first one has 8 ones, so 1 is red. Let's go to another color, orange. What else do we have? Okay, we do have this and this. Oh, and we have also this and this. They are adjacent because you should wrap it. So again, the next one has 8 ones in it. So these 2 and on top of that. So this is another one, 2. What next? Well, let's go to yellow. Okay, what do we have here? We do have 4 ones here, which that's it, nothing else. So the number 3 has 4 ones in it. What else do we have? Okay, 2 ones, yeah? We have 2 ones on top of each other. So let's select green, light green. So this one and this one, they are grouped together. So number 4 is these 2. What else do we have? So these are grouped together. I don't see anything. Do you see? Which one? Oh, perfect. Yeah, so this is another one. Perfect. Blue. So this is another implicant, number 5. What else? What? Which group? Red. Okay. You are going to essentials now. Okay. Let's make sure that there is no implicant, no prime implicant. It seems not. Yeah. So let's go to essentials. So for essentials, with the red one, we start with the number 1. Highlighter. Number 1. For number 1, you could see these, that one, they are not covered. So for sure, number 1 is essential. Okay, so number 1 is essential. Is selected. Now we go to number 2. Number 2 is these, so these 2 are already covered, these 2 covered, oh, this 2 is not covered. So this and this one, they are not covered. So number 2 is also essential. Let's go to number 3. Number 3, this one, okay, that one is not covered by anything. So again, this one is essential. Number 3. Number 4. Number 4 is these 2 ones. These 2. This one is covered, but this one is not covered. So this is also essential. Number 5. Number 5. Number 5 is this one. So it seems that it is not essential because this cell has already been covered. This cell is covered by the green one. So number 5 is not essential. So we have 4 essentials. Let's pick them and write the equation. Before writing the equation, let me select the things that we have covered with pen. Okay, with essentials. Number 1, essential number 1. So we have covered these. Number 1. With number 2, we have 8 ones. So these already gone. These already gone. So number 2. Number 3, we cover this, and the next 2 is already there, marked. Number 4, covering this and this. Okay, that's it. Now let's see which one is left. Who was trying to find which one is left? Ask me something. Maybe you were the one, yeah? Yeah. So look if there is any one left. No, it seems that they have tick. They have marked. So that's it. We don't need this one. We just write the equation with these 4 essential prime implicants. Okay? Make sense? Following? Okay. So the equation would be, what is the equation? These 4. Yeah, they are the selected. And the equation would be this. 4 terms. 2 of them are group of 8 ones, and 1 is group of 4, this one, and this is group of 2, this, the number what? Number 4. Okay, so that's it. We don't need to add anything. Yes. Okay. We have 5 variables. Okay. So if you have a group of 2, it means that there is a term common between these 2. So one of them is gone, the next 4 is remaining. If you have 4 ones together, so it means 2 of them are gone and 3 is left. When you have 8, then it is 2 left. Because it is 5 variable. If we were in 4 variable, when you have a group of 2, then it means 1 is gone, you have a term of 3. You have a term. If 4 is gone, if 4 is grouped, then you have a 2. And if you have 8, it means 1. Yeah.
So if they are in both tables, then the A's cancel out, correct?
Yes.
And then if it's only 1, then it's either whichever one's A or A.
A is cancelled.
But if it was in one.
Oh yeah, so if it is 1, so it should be A, and it is either, this side would be A naught, this side would be A.
Yeah, like that.
Yeah, for example, this one, let's see what is this. Let me erase everything. This is B naught, C naught, and A naught. Yes. A naught, B naught, C naught. Okay. If we want to go to 6 variables, again, we cannot have more than 4 by 4. So you have to put 4 of them, and then you have to imagine good. It is difficult. That, for example, this with this, with this, and this, they can group. So it's a little bit hard, and so you have to work on that. Okay, now let's go to the next topic. Don't care. So what is don't care? Up to now, we had a function, we listed SSOPs, we wrote it as SSOP, we listed the min-terms, then we put them in a Carnot map, and then we group the Carnot map, and so on. Sometimes, when we want to design a function, to define a function, some of the inputs are not important for us. We don't care about what are these inputs make, what would be the output of these inputs. The inputs are not valid. We shouldn't have those kind of inputs. So it is not important for us. If they come, what would be the result? So we don't care of the result of those inputs. Let's see BCD. Do you remember 7-segment? 7-segment example that we had before. The 7-segment had 7 segments like this. And then it could display the number values from 0 to 9. Let's say we have a BCD system, just the numbers goes from 0 to 9. We are not talking about hex. So 0 to 9. So for that, the input is the BCD number from 0 to 9. The output would be something that will turn on the corresponding segments of these 7 segments. We want to design this function. Okay, you have to design a function, a circuit. This is a circuit with AND and ORs, which gets 4 inputs corresponding to BCD, and generates 7 output for these 7 segments. Okay, the input would be 0, 1, up to 9. This is the last one. So we don't have more inputs. We only have 10 inputs. The next inputs, 10, 11, 12, 13, 14, 15, they are not valid. It doesn't make sense. It doesn't mean anything. We just need to have a BCD number and display it on the 7 segment. So it is not possible to have, for example, 11 at the input. It's just a digit, 0 to 9. So outputs are 1 for the input BCD values that force the function to 1. So we write that. And for other valid BCD values, the outputs are 0. Let's see. For example, do I have an example here? And there are invalid BCDs which are not, okay, here is an example. Let's say, for example, we want to find the function of, we had 7 outputs. Let's consider one of them. Which one? I guess this one is easy. Which one is easier? I don't know. Well, let's consider one of them. I don't know. For example, let me see what I picked before here, so I select that one. What is that? I didn't put. What is that? This is the one that has 1 for 0, 0, 2, 3, 0, 2, 3. Which one has the one of 0, 2, 3? Sorry that I don't remember which one I picked up. 0, 2, 3, 0, 2, so no 1, 2, 3. Oh, I guess this is the one. This segment, the A segment. You remember that we called them A, B, C, D, E, F. A, B, C, D, E, F, G. We had 7 segments, and each one of them, A to G, is an output. We want to output, to turn it on or off, based on the number that we input. So look at segment A. Segment A is on when we input number 0. When we input 0, we want it to be on. When we put number 1 at the input, it is not on, it is off. It is off. When we put 2, it is on. When we put 3, it is on. When we put 4, it is off. 5 on, 6 on, 7 on, 8 on, 9 on. So if we write the truth table, it would be this truth table. Now let's go to the card map. So one by one, A, B, C, D, E, F, G. We have 7 outputs, and we have to design 7 circuits for each of them. Now we just use A as an example, segment A. So if we write the Carnot map of this, you see the I have something that is not, okay, no, I don't have it. So you see, this is another example that I put it in the horizontal, because in your book it uses this notation. I just put it so you get familiar with both. In this notation, W, X, Y, Z. So the number goes from here. So this is numbers 0, 1, 2, 3, then 4, 5, 6, 7, 8, 9, 10, 8, 9, 10, 11, and then 12, 13, 14, 15. Usually up to now, whatever we tried to solve, we were vertical, 0, 1, 2, 3. Now it is horizontal. It doesn't matter. It's another notation. We just put WX at this side, YZ at the horizontal side. Your book is doing this notation. So if you read the book, you see this notation. Anyhow, segment A was on 0, 2, 3, 0, 2, 3, 5, 6, 7, 8, 9. And it was not on these numbers. It was not on number 2 and number how much? 0, 1, 2, 3, 4. Number 4. You know? You see? Number 1 and number 4. Segment A is not on number 0 and number 4. Okay? Following? Okay. So this is the Carnot map. And we have put 1 as 0 for inputs from 0 to 9. So what about the rest? Input 10, which is this one, which corresponds to this. This is 10. Input 11, input 12, input 13, 14, 15. What about this? Should it be 0 or should it be 1? We don't care, because the input it shouldn't be 12. We don't have 12 as an input. We don't have 1, 1, 0, 0. No way, because we have from 0 to 9. 1, 1, 0, 0 is not a valid input. So we shouldn't think of that, and we shouldn't design for that. We don't care. For these yellow ones, we don't care. So what to do? Now we want to make a simplified version. So either we should put 0, put 1, we don't care. Whatever you want to do, put it. So let's say we put 0 for all of them. We put 0 for all of them. Okay, let's see what happens if we put 0 for all of them. Again, starting the Carnot map, what implicant do we have? We have 1 here. So this is number 1. We have one here, number 2. We have we can group these 2 corners at the top together. Why it's not coming? Yellow. So yellow 1, number 3. Then we have the 2 corners at the left. Two corners at the left, this one and this one, number 4. Okay, we do have another one here. Green, blue, no. Okay, purple. This one is another one, 5. Do we have more? I don't see. Do you see any more groups? Seems not. Okay. So let's find which one is essential. Okay, for number 1, this 4, this is essential. So we, no, this one, very bad. Number 1, this one looks good. Okay, this one. Okay. Number 2, this cell isn't covered by anything else. So this is also essential. Number 3, this is already, it could be covered by green. This also could be covered by blue, so this is not essential. Number 3 is not essential. These 2 are. Number 4 is these 2. So again, this one has common with red, this one has common with yellow, so this is not essential. Number 5, this one is not covered by anything else, so this is also essential. Now, let's put the ones that has already been covered. One is this one, this one, this one, this one, this one. 2, this and this. 3, no. 4, no. 5 is this. So is there any one left? Oh yeah, this one is left. And we have 2 options for that, either the yellow one or the green one. So you could write now the thing. Okay, these are the 4 ones that are essential, and the next 2 would be either this one or that one, whatever you want to pick. So it's up to you that you pick anything you want. Okay. So this is when we put zeros for that. But what if we put ones for that? All of them 1. Because we don't care. We could put 1 there. So let's put 1 for all of them. I guess I have it there. Okay, no, let's do it. 1 for all of them. 1, 1, 1, 1, 1, 1. Now let's group. Yes.
So like yellow boxes, how do you know which boxes are like don't care values?
All of them. The yellow ones are don't care.
How do I know?
Because the input for our function is only cells from 0 to 9. Cells 10, 11, 12, they are not the input, the valid input. We never get an input like that. It never happened. So when it never happened, so why do we think about it? Just put it, don't care. Now I put 1 for all of the don't cares. First I put 0, we calculated, and it was the result. Now I put 1 for all of them. Okay, if I put 1 for all of them, okay, we have better groups. The first group is this one, number 1. The next one could be these 4. These 4 together. Oh, this 8. Why this 4? This 8. So the next one is 8 group together. And then we have, like before, we have this. No, this one. This one is better. This 4. Number 3. Last time we had only those 2. So now we have a 4, a group of 4. Then what else do we have? This one. Okay, this one we could blue, purple. No, purple is similar to that red. Okay, these 4. This, and that one. This is another one, 4. Do we have more implicant? Look at that. Oh yeah, there is one. No, we had already put 8 of those ones. So we have 2 8 ones and 2 4 ones. I guess that's it. Yeah. Do you see any more? Okay. Which one is essential? Which one is essential? Let's see. So the number 1, which is this, these 2, no, this is not covered by anything. So it makes it essential. Number 2, which is these 8 ones. So for example, this cell. So number 2 is essential. Now, yeah. Which one?
8 and 8.
Yes, 8 and 8. Yeah. First one is this 8. Second one, number 2, is this yellow one. Okay.
Why did you choose the first one as essential? Because it's covered twice.
No, here, this one, this.
Yeah.
This. Oh, yeah, it is in yellow. Why didn't you tell me? Yes, you are right. So what about this? Okay, this is not covered. Do you agree? It is essential. Yeah? Yeah, this is not covered by. Yeah, you are right. This is not correct. This is covered by, because I put yellow one at first like this, then I didn't notice that the yellow is the whole thing, not just the one. Okay. So 1 and 2 are essential. 3. 3 is these 4 ones. So these 2 no, these 2, one of them no, but this one is not covered. So this one also covered. 4, this one has something that. So all of them are essential. So let's write it down, and then I write it in the next column. So what do we do now? Why do we select zeros? Why do we select ones? And why do we do it? Maybe some of them 1, some of them 0. You can do whatever you want. So what to do? What we do is that we put minus as don't cares. Then we try to group, we consider them as ones to make bigger groups. Then for selecting essential prime implicants, if there is only symbol minus, then we don't select them. Let's see. Here, actually, in this example, if we do this, we reach the same thing. The result would be the same as if you select all ones. If you put all ones here, we see this, and this is what there were 4 essential ones, and this is the function. 2 8 cells and 2 4 cells. Okay, but now let's see another example. In this example, I want to show you that no, it's not good to always put all of them as 1 and calculate. Sometimes it is not necessary. So I put dash for don't cares. Now let's okay, what is this function? This function is the one that it's going to find out the prime numbers between 2 and 11. So yes.
Okay, for the example, more like how, what are we, like, are we supposed to choose whether they're 0 or 1s? Like, is there like a preference?
We did 2 things. First, we put 0 for don't cares. Then we put 1 for don't cares. And for the zeros, we reach this function, and for ones, we reach this function.
So we want to have multiple
But now I am telling you how to find the best one.
Okay.
Just before trying, we tried both, and it is obvious that the one is better. Now, even if you put all ones there, it is not always the case that it is better. I am going to show you how to do that. This example is the function that generates, that detects prime numbers. Prime number, you know prime number. 2, 3, 4 is not prime. 5, 6 is not. 7, 8, 9, 9 no, 8 no, 10 no, 11, 12 no, 13. Just to that, up to 2 and 11. So I don't go to 13. So the numbers between 2 and 11, which are prime, we want to detect them. And the other numbers, 0 and 1, and 12, 13, 14, 15, we don't care. The function that we want is to find the prime numbers between 2 and 11, 0 and 1, and 12, more than 12, we don't care. So again, number 2 is prime. Number 2. Number 2 is this one. Number 2. 0 and 1, we don't care. 2 is prime. 3 is prime. 4 is not prime. 5 is prime. 6 is not prime. 7 is prime. 8, no prime. 9, no. 10, no. 11, yes. And 12, 13, 14, 15, don't care. So this is the kernel map of that. The numbers, the input numbers which are prime, generating 1. The numbers between 2 and 11, which are not prime, making 0. And the rest, don't care. Either we don't want them. We just want to calculate this. Okay? Now let's start. As I told you, to make implicants and to make groups, consider the dash ones as 1. So you make a bigger group. Okay, let's do that. So the first one. Okay, let's see what could we do. Okay, I guess I could select this, number 1. Number 2, I could select this. You see, I covered the dash also. Number 2. Number 3, I could select this. This is number 3. Okay, number 4. I guess this would be number 4. Number 5. What do I have more? This one, this. That's it, yeah? No more? Seems not. So I had 4 prime implicants. Now find the essential ones. Here by essential we means that there is one which is not covered. So we don't care about the dash one. So if there is a dash in a group which is not covered, who cares? But we select those prime implicants who have one which is not being covered by anything else. So let's see which one is that. For the first one, highlighter. So for the first one, the red one. So it has these 2 cells is dash. No. This one is already covered. Is covered by something else. This one. What about this? No, nothing is covering this. So this is essential. Number 2 is the orange one. The orange one, so this is covered, this is covered, this, no, nothing is covering this one. So this is good. Number 3, number 3 has no one, so we don't use it. Select it, yes.
You can make another implicant
BD.
So the square right in the center.
Oh, perfect. So number 5. I put dark blue. Number 5, very good. Here is the what is yellow, green, why yellow? This one. Number 5 is this. Very good. So let's go back to prime, to essential. So number 2, yes. Number 3. Number 3 has no one. There is no one here. So this is not essential for now. Number 4. This one is covered. This one is covered. This one don't care. This one, yes.
Isn't it because 5 exists now and it covers 2? 2 is no longer.
Oh yeah, we didn't. Yeah, at that time we didn't have number 5. So which one you are saying? Number 2, you mean? Number 2. Number 2. This. What about this? No, this is don't care. Okay, this is covered. This is, yeah, you are right. So number 2 is minus. Perfect. Very good. Because at that time we didn't have number 5. You are right. Number 4. This, and what about this? This is not covered. No. So we have to select number 4. Number 5. Number 5 is here. It has 2 ones, which is covered by something else, and it has 2 dash, which we don't care. So this is also not an essential. So we have only 2 essentials. We select these 2 essentials and see what is left. So you noticed that when I wanted to select the essential ones, I didn't select the ones that have dashes. I didn't look at dashes. They don't care. For grouping, I considered the dashes to make the groups, but for essentials, I didn't. Okay. Now let's see which is covered and which is not covered. Okay, number 1 is this. So this one is covered, this one is covered. The first 2 is don't care, so I don't care. Number 4, this one, and this one is covered. So what else remained? We have covered this. There is 1 left, yeah? Do you agree? No more ones. Only this is left. I put highlight yellow. This is left. So we should select one implicant which covers it. Two implicants covering that, both of them are 4 number, a group of 4, so they are similar. If there was an implicant with 8 group, a group of 8 ones, and the one with a group of 4, we would select the one that has more ones because it is a simpler term. But here, both of them are 4, so we select one of them. That's it. And either number, so it would be either number 2 or number 5. So we have 1, 4, and either number 2 or 5 as our function. You see, number 3 is gone, and one of the 2 and 5 is also gone. So these are the ones. Yeah, and okay, here is this solution. And if we select the other one, this is number 5, this is number 2. Here selected 2, here selected. So either, so both of them have CD and A naught B naught because they were essentials. But the other one, you have a selection, you have an option, either A naught D or either BD. Okay. I guess we go to quiz now. Quiz. It is 12. Okay. 12:50, and the password is Carno, all small letters, no capital. Carno, Karnaugh, and save and close. Oh, start date must be before end date, isn't it done? Oh, 12 p.m., not a.m. p.m. Save and close. Okay, so it should be here. Yes, Carno map 2. Please start. The password is Carno. You should do it fast. 9 maps.